All right, good morning. Yesterday, I started lesson 3.2 and I got through a couple of objectives. I think there's 8 objectives, but just to let you know, I'm going to finish the lesson today and we're going to have an exam, and it's not going to be in next Friday, March 12th. And so I'm not going to stop teaching. I'm going to keep teaching, but just to let you know, if you want to mark it down, exam 3.1 to 3.2, Friday, March 12th. All right, now I just started getting into the graphing. So that's where I'm going to pick up today, and then I'm going to finish the lesson. Do you want to ask me any questions about problems 1 through 40, one odd at all? Anybody want me to work any problems, or anybody have any questions about those problems? No? All right. So yesterday I was talking about the definite logarithm, and we were writing in, we were taking exponential form and writing it in logarithmic form and vice versa. We also looked at some properties of logarithms. We looked at log base b of b to the x equals x. We looked at log base b of 1 equals 0. And we looked at the log base b of x equals x. And I was explaining the base of the logarithm and the base of the exponent cancel each other out. And so that's where those properties are called inverse properties. And yesterday I did a couple of graphs where I showed you exponential growth, and I showed you the inverse, which was the logarithm. So what I want you to get out of that is that exponential growth has a horizontal asymptote at y equals 0, and it runs along the x-axis. The logarithm has a vertical asymptote at x equals 0. It runs along the y-axis, and the point, just switch. All right, so what I want to do is I want to do one more parent graph with exponential decay. All right. So that is a parent for exponential decay, and they're giving us g of x, which is the inverse. It's log base a half of x. Those are both parent functions. This graph is going to go up like growth does, and this graph is going to go up along the y-axis and up like that. So it's a little bit different. This one runs along this horizontal asymptote. This guy runs along a vertical asymptote. So I'm going to do this exponential decay. Actually, I'm sorry. This is decay, so it's not growth. So the decay falls along the horizontal asymptote, and you're going to see this guy. He's not going to go up because he's decay. He's going to go down like that. This is along the y equals 0 asymptote. He's falling along the vertical asymptote x equals 0. So if you were going to pick the parent points, we pick 0 because 1/2 to the 0 is 1. And if you pick 1, 1/2 to the 1 is a half. And we know this guy has a horizontal. So we graph 0 up 1, and we graph right 1 up a half, And like I said, because this is decay, it's going to be falling along the x-axis. Now, when I talk about this like I am today, I like to draw the identity. The inverses flip over the identity. So look, parent points for the exponential decay. Like I said, you may not have, so you want to try to come up with your points on your own. So what x would you pick?
One.
Right, because log base a half of 1 is 0, so log base anything of 1 is 0. And then the next one you're going to pick is 1/2. So log base a half of a half to the 1 is 1. So you're getting these points according to the properties we looked at yesterday. And here's the deal. Switch, that's what inverses do. So instead of 0, 1, it's 1, 0. Instead of 1, 1/2, it's 1/2, 1. So inverses switch, and the asymptote is vertical. So right 0, and this is right a half up 1. And remember, he's falling along the y-axis. And can you guys see that's a reflection over the identity? See how this black became the red and that black, that red? So this is absolutely showing inverses. So that is f of x, and the red one is g of x. Okay, any questions about the parents and how you're finding the points? So most people would get confused with this. Okay, so now I want to move on to parents, and I want to look at transformations. And I don't have anything new to teach you because you're going to use the transformations of the quadratic that I gave you before. So once again, you want to know what A, B, H, and K do to a graph. You want to know the order. Stretches and compressions, reflections. So here's the equation. Now you haven't seen this, but it works just like the quadratic. So remember the quadratic, it looks like a times bx minus h quantity squared plus k. It also works like the absolute value, the cubic, the cube root. They all work the same. So A is a vertical stretch or compression over the x-axis. B, which is inside the of the quadratic, it's inside the logarithm. Horizontal stretch and flips over the y-axis. This is left and right, and that's up and down. So what I want to do is I want to put up a bunch of problems, and I want to make sure that you know what A, B, H, and K do to a graph. Now, what is that A, B, H, or K?
H.
Okay, is it in parentheses?
No, okay.
It's not in parentheses, so it's K. So I don't care what it looks like. If it's in the parentheses, it's B and H. If there's no parentheses, it's A or K. So this is down to. Can you see the difference in that problem and this problem? Is this A, B, H, or K?
H.
Right. So what is this doing? Is this doing right 2 or left 2?
Right 2.
Right 2. Now, remember that A is multiplied to the logarithm. This is A times a log. Is this A times a log, or are they trying to trick you?
They're trying to trick us.
Right. So we should rewrite this as log base 3 of x plus 2. So what is that really? Is that A, B, H, or K?
Okay.
And so what is that?
Up to.
Up 2. Okay, I'm going to try to trick you now and see if you can get this one. So that's log base 3 of 2x. Is that A, B, H, or K?
B.
It's B. So is that going to be a horizontal stretch or compression?
Horizontal compression.
Yes, good. It's a horizontal compression because you have to take the reciprocal. Remember? Good, Mark. So what about this guy? If he's a horizontal compression, what's he? That's A, right? So what's A?
Vertical stretch.
A vertical stretch by 2. So you just have to remember, with B, you have to take the reciprocal. With A, you do not take the reciprocal. Let's do a couple more. What do you think about this guy? -1 times the log base 4 of x. What's that?
A.
Yep. And what does A do? When it's negative, what does it do?
It's a reflection.
Reflect over
Reflect
y.
over what? I'm sorry, what'd you say?
Reflect y.
Y or X when it's outside?
X.
Okay, so if you have a negative inside like this, that's what? A reflection what?
Over the Y.
Over the y-axis. All right, now everything we just did here is just basic transformations with the parent. All right, you guys ready to try a graph? Yes, we're ready. Now remember, just like the exponential growth and decay, your parents are all going to be different depending on the base. Ready? Gonna graph. I don't want to do that one. Hold on. Let's do x minus 4. All right. Who's the parent? Go ahead, I'm listening. Who's
Log base 3.
so what points you gonna pick? And we know there's a asymptote at x equals 0. In fact, let's draw that. All right. Give me an x.
1, 0.
1. So log base 3 of 1 is 0. Give me another x.
3.
Log base 3 of 3 to the 1 is 1, right? Because they undo themselves. They're inverses. Log base, a log and a base of an exponent undo themselves. So let's graph that. Right 1, 0. Right 3, up 1. And remember what the logarithm looks like? It looks like it goes up along the y-axis. It goes up along the vertical asymptote. And like I said, I would draw the idea. No, we don't want to do that. We don't want to draw the parent. Forget that. I was thinking I was doing another problem. We don't want to do the parent. Who cares about him right now? Okay. All right, so just leave that. All right. What does this mean, guys? What does this mean? Is that H or K? Is it in parentheses or not?
It's K.
So what's it mean?
Down 4.
Right. So you come here and you go, down 4 means the Y. Down 4 means the Y. And now let me ask you something. Remember with exponential growth, the horizontal asymptote was changed by K. Who do you think changes a vertical asymptote? If you have a vertical asymptote, do you think K is going to change it? It already goes forever up and down. Does K change a vertical asymptote?
No.
So who's going to move the vertical asymptote?
H.
H. So since 0 here, asymptote stays the same. Nobody moved him. So impressions, reflections, those. The only thing that's going to move a vertical asymptote is left or right, which is H. So we got the points. Right 1, down 4. 3, down 3. And it's like, what were we doing? That's why I drew this little picture, right? He goes up along the asymptote like this. All right, so what's the domain, guys? So remember, growth and decay, the domain was forever left and right. Now, because they're inverses, the range is going to be forever left and right. I'm sorry, the range is going to be forever up and down. So what's the domain? Domain?
From 0 to infinity?
Yeah, exactly. So not only did the ordered pairs switch, the domain and range with the inverses switch. Pretty cool, huh? Remember the exponential growth, the domain was forever left and right. And now for the logarithms, the range is going to be forever up and down. Do you guys have any? Let's do another one. You guys have any questions? Let's do another one. And by the way, I like the way the book did this because these are all real simple. So these are all real simple graphs. They're not making the transformations complicated. So they're real simple transformations, and I'm glad they did that with the logarithms. Okay, now this guy's parent is log base 2 of x. And there is a vertical asymptote at x equals 0. So what points you guys want to pick? Give me an x.
1.
What's log base 2 of 1?
0,
Okay, give me another x.
2,
Log base 2 of 2 to the 1. So what's this? Say
H,
what's that say?
left 3,
Because this has to be written as x minus a negative 3, just like all the other functions, right? So left means x. So subtract 3, negative 2, subtract 3, negative 1, and the y stay the same. What happens? What happens to the vertical asymptote? He's not at x equals 0 anymore. Where is he? Who moves the vertical asymptote?
H,
Right. So where's the vertical asymptote now?
negative 3,
So you draw the asymptote. Once again, this is just logarithm and there's no reflection or anything. So he's just going to go up like that along that asymptote. So you have left 2, 0, and you have left 1, up 1, and you just draw the graph along the asymptote. All right, go ahead and tell me, what's the domain?
negative 3 to infinity,
Open on negative 3 to the right forever. What's the range?
negative infinity to infinity.
Forever up and down. They're going to ask for the domain and range, so make sure you know what you're doing. You guys want to do one more problem with the reflection?
Yeah, please.
All right, now the parent does not have that negative. The parent is just log base 5 of x, the most basic graph. With the vertical asymptote at x equals 0. Let's think about this for a second. This logarithm went up along the y-axis, but what is that guy?
A reflection,
Reflection over what?
X,
X? And what's that guy? Is that A, B, H, or K?
K,
So look at this. If we left over the X, shouldn't our graph look like that? Yep.
yeah,
Back over here, if I pick 1, log base 5 of 1 is 0. And if I pick a 5, log base 5 of 5 to the 1 is 1. All right. Watch my arm. Reflect X is vertical, right? Vertical. So I negate the Y, right? So you leave it alone and you negate the Y, and down 2 means subtract 2 from the Y, right? So subtract 2 would be negative 3. And what happens to the asymptote?
Stay 0.
Yes. Who is that? Jerry? Is that Jerry or
Yeah.
Victor? Yeah, Jerry. Good job. So it doesn't do anything because we remember who moves the axis, left or right, and we have a K. Good job. All right, so we're going to graph right 1 down 2. We're going to graph right 5 down 3. And I don't know about you, but that's confusing. So that's why I drew this little picture. This little picture is saying run it along the y-axis like this. Right?
Yes.
Yes. Okay, so what's the domain?
Zero to infinity.
From 0 to the right forever. What's the range up and down? Negative infinity, right? Okay, now I have like one more thing to show you with the graph and we'll be done. Do you guys have any questions? Objective 7 talks about common logarithms. So if you have f of x is equal to log base 10, you are never going to see that. So what you're is this. So do you guys remember that x is really equal to 1x, but we don't ever say 1x. We know there's a 1 there. It's the same with the base logarithm. When you read this to me, don't say log of x. That's wrong. It's log base 10 of x. Whenever you don't see a base, it is 10. Your calculator is base 10. So if you try to graph log base 3, you can't do it. The calculator is base 10 calculator. On the calculator, you'll see that's log base 10. So I just want you to know that that's what it means. That's a base 10. And you want to write that your calculators are based on logarithms. They are base 10 logs. Now I just want to talk about the parent points for this real quick because you see them a lot. What would be the parent point? What x are you going to pick?
1.
Log base 10 of 1 is 0, so that one's easy. Now which one are you going to pick?
10.
If the base is 10, you're going to want to pick x equals 10, so you have log base 10 of 10 is 1. That's exactly right. Good. I got one more thing to show you. Half of this last thing I'm going to show you. Is it okay if I erase this? Yes?
Yes.
Something called, this is objective 8. It's called a natural logarithm. You have a common logarithm, which is base 10, and natural logarithm, you're never going to see that. What you're going to see is this. ln of x. But let me assure you, this means log base e. So the way you read this, you say the function f of x is equal to the natural log of x, but just know that it means log base e. And remember, e is that number 2.7, remember on the calculator? 2.7. So let me show you a graph of that. So let's graph a natural logarithm. Those of you who came into class late, please don't come into class late. It's disrespectful. And I did mention that we have an exam next Friday. So not tomorrow, but next Friday on 3132. So you're missing a lot of important announcements coming into class late. And you are disrespecting me by coming into class late. And I don't appreciate it. I would never disrespect you intentionally. So please don't disrespect me. I'm standing up here teaching for you. Be on time. All right. So let's say we want to graph this. Now that is not an I, it's an L. So it's a natural log, and they might say something like this. So the parent is going to be log base e of x, right? Those are equal. So what points are you going to pick? Go ahead, Mercy.
1.
So log base e of 1 is 0. And now what are you going to pick?
E.
Exactly, because e is 2.7, right? So log base e of e to the 1 is 1. That is correct. Okay, now, this logarithm, he goes up the y-axis like the log logarithm. State the transformation.
A left one.
Left 1. So you're going to move this guy. Left 1 would be 0. Left 1. Now, isn't this 2.7 minus 1.0? So wouldn't this be 1.7? Yes or no?
Yes.
You guys see what I did? The E number is 2.7. You have to subtract 1, make sure you line up the decimals, and that would be 1.7. Now, does the asymptote change or not?
Yes.
What's the asymptote? X equals what?
-1.
Thank you. So you graph it, and you're going to draw the vertical asymptote at x is equal to -1. You're going to graph the point 0, 0. And this is going to be 1 7/10. Now, I'm going to show you this. This means 1 7/10. So that means between 1 and 2, 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not talking about the tick marks. I'm talking about the parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7 out of 10. 1, 2, 3, 4, 5, 6 would be there. So we go right 1 7/10. Just say there. And we go up 1. And there was no reflection or anything. So we just run them up along the asymptote. So what would be your domain?
-1 to infinity.
Right, from the asymptote would be -1 to infinity. So from -1 to the right forever. Okay, that is the lesson. And here's what I'm going to let you do today. You're actually going to stay here. And if you need help, you're going to send me a message. It just says help. And you're going to go to Math Wizard Team 1, and it's going to be me and you, me helping you. All right, so let me say that again. You're going to stay here. I'm going to take attendance in here. You can mute yourself. If you need help, send me a remind message. Just say help, and I'll meet you in Math Wizard Team 1 to help out. All right, so I'm giving you this opportunity to work on the assignment. Okay, are there any questions? All right, well, let me know if you need help. We will not be reporting back here. So just let me know if you need help with the assignment. Okay? All right. You can just stay here, and I'm just going to mute myself. Anybody have any questions? Anybody want to ask me about anything? All right.